Hi one and all, welcome to this video. In this video, I'm going to discuss about the network topology which I have created for an organization, and it has three different locations. Site A is Waterloo, Site B is Kitchener, and Site C is Gulf. As we can see in this diagram, there is a legend on the right hand side which describes about the label and the IP address assigned to each object in the topology. In this topology, I have connected three edge routers from three different sites, and they are connected to each other forming a daisy chain. The edge routers are connected to the access routers in each site, and the access routers are connected to the LAN network. So basically, for all the workstations in that site, access router acts as a default gateway. I have assigned IP address to all the devices, and I have used a single IP address network range and divided the IP address range into different subnets with /28 CIDR. So basically there will be 16 hosts in each subnet. So 14 hosts which can be used, and one network address and one broadcast address. So we'll start with discussing about the basic configuration which I have done on all the network devices. I have configured message of the day banner, password for privilege mode, password for console ports, password for virtual terminal ports, and I have also created SSH key which will be used for SSH protocol. So let's look at the configuration on this access router of site A. As I mentioned, I have defined the host name for this router. I have defined the password for the privilege mode, and it is in encrypted format. I've also defined the domain name as itns.local, which will be used for generating the SSH key. I have defined the message of the day banner, which will be displayed to all the users when they try to connect to the device. And also, as you can see, I have defined password for the console port and virtual terminal ports. As we can see that these passwords are not in clear text format. So basically, I have used password encryption service on this access router, which is going to encrypt all the passwords which will be stored in the running configuration. So it's basically a method of trying to protect those passwords by hiding them, or basically by encrypting them. Now we will discuss about each site in detail initially, and then we will discuss about the dynamic protocols which are configured on the routers, which will help them to learn about the network paths in another sites. So let's start with site A. As you can see in site A, the access router is connected to switch 1, and switch 1 is connected to switch 2 and switch 3, forming a loop. There are two servers which are connected to switch 2, and one workstation which is connected to switch 3. As we can see that the two servers are web server and TechX server. So here, as I mentioned earlier, I have used SSH protocol, which will be used for remote connection, and I'm going to use TechX server or TechX authentication for authenticating the users who are trying to use SSH protocol for remote connection. So let's look at the configuration of TechX server. I have enabled AAA service on this server, and I have added the edge router and access router as the client. I have also defined the secret key, which will be used for authentication, and the same key I have configured on the router. So I'll show you the configuration for that later on in this video. I have also created a user which will be used to connect to the access router and the edge router. So let's look at the configuration on the access router, which will be kind of similar, and it will be used for ensuring AAA authentication. So here, as we can see, I have used AAA authentication and defined the login group which will be used. Also, I have defined the TechX server host, and this IP address is of the TechX server here. I have defined the same secret key which will be used for authentication. So using this, we can try to connect from this workstation using the user which we have created, and let's see if we are able to authenticate the user using TechX or not. This is the IP address of access router, and here it is asking me for the password. I'll enter secret 55, and we are successfully authenticated. So basically, this is going to ensure confidentiality and security. Now, all the three switches are connected forming a loop. So to avoid any network jam, I have defined spanning tree protocol on all the three switches. Also, switch 1 is a root bridge for VLAN 1. So basically, both the ports of switch 1 will be in the designated mode or are in the forwarding mode, and they are basically the designated ports. The link which is connected to switch 2 and switch 3 will be the root ports because they are connected to the root bridge. The link here which is connected from switch 3 to switch 2 is in blocking mode. So basically this port will be used by the spanning tree protocol to break the loop. So let's look at the configuration of spanning tree protocol. As we can see that this switch is the root bridge and all of its ports are in forwarding mode and they are designated ports. Let's look at the configuration of spanning tree protocol on switch 2. So here, this interface is the root port because it is connected to the root bridge. But this interface is in blocking mode. So basically, as I said, this port is going to be used by the spanning tree protocol to break the loop and prevent any network jam. Now I have configured a web server and I have defined a custom home page on this web server. So whenever any user tries to connect to this web server, they will be displayed with a custom home page. So this is the custom home page. We'll try to access this later on in this video. Now we'll look at side B. On side B, as we can see, there is switch 1 and switch 1 is connected to switch 2 and switch 3. There are two workstations connected to both of the switches and both of these workstations are in different VLANs. So I have created VLAN 10 and VLAN 20 on both the switches. Now I want to configure VLAN inter-VLAN routing on this side. So what I have done is I have first configured VTP, that is VLAN trunking protocol, on all the three switches, and I have made switch 1 as the server and switch 2 and switch 3 will be the client. So basically the server is going to synchronize its VLAN information with both the switches, and accordingly both the switches will get all the information of VLAN. So let's look at the configuration on switch 1. As we can see that this link which is connected from switch 1 to switch 2 and 3 and the link which is connected to the router, access router of side B is in trunk mode. So trunk mode basically means that when we want the information to be transmitted from multiple VLANs on a single link, we have to define the link as trunk mode. Also, I have enabled encapsulation.1q. So basically, encapsulation will be used when we want to tag the packets with the VLAN ID. So let's say when PC1 is going to send a packet to PC2, which are on two different VLANs, the switch is going to tag that packet with the VLAN ID of the source and the destination. So this is going to be very easy to identify for the switch as well as for the router. So similar configuration has been done on the router, which I will show you later on. Let's look at the VTP configuration. And as we can see that this switch is in server mode. Also, I have defined domain as RM1930. So all the two switches which are connected to switch 1 will also be in the same domain. We can look at the configuration for switch 2. So this switch is in client mode and it is also in the same domain. Also, I have defined passwords for VTP on all the three switches. Now let's look at the VLANs which I have created on switch 1 and accordingly it will be synchronized on both the switches. So I've created two VLANs, VLAN 10 and VLAN 20, and I have defined names for them. And the same VLANs will be present on both the switches, VLAN 10 and VLAN 20. Now, the links which are connected to the workstations will be in access mode because they are connected to the workstation. So it should be one-to-one link. Like for VLAN 10, this PC, the link will be active from the switch to the workstation. So we can look at the configuration for that in the running configuration file, and we can see that this switch port is in access mode and it is assigned to VLAN 10. Now, to allow the workstations to communicate with each other in different VLANs, I have defined inter-VLAN routing. So for that, I have created two sub-interfaces on this link of access router, which is connected to the switch. So let's look at the configuration of inter-VLAN routing. So I've created two sub-interfaces .10 and .20, and I have assigned IP addresses to them in different subnets. Also, I have enabled encapsulation.1 queue. As I mentioned earlier, it is going to be used for VLAN tagging. Now, this IP addresses of two sub-interfaces will be the gateway for these workstations in VLAN. So we can try and ping from PC1 to PC2, and let's see if they are able to communicate or not. And yes, we are getting a successful response. This means that both the workstations can communicate with each other, even though they are in different VLANs. Also, I have used Radius server over here for authentication of SSH protocol. So the configuration is similar to that of TechX server, which I have done on site A. I have defined AAA service on the server, and I have added access router and edge router as their clients. Also, I have created a user RM1930 which will be used for authentication. So we can try to connect to the access router from this workstation. And it has successfully authenticated the user, and now we can take the remote of this access router and configure it. On site C, as we can see, there are three workstations connected directly to the access router, and these three workstations are connected in different subnets. So I've configured three different subnets on this link. Now we can try and check if the workstations are able to communicate with each other or not. I'm trying to ping from PC1 inside C to PC2 inside C, and we are able to communicate with each other. Also, I have defined SSH protocol on access router and edge router, but here I am not using any third-party service for authentication. I have defined local authentication on both the routers. So we can try to connect to the SSH protocol for remote authentication and remote connection. And this is also working as expected. Now, all the three edge routers are connected to each other. So I've configured EIGRP dynamic routing protocol on all the three edge routers so that they can share their network, they can share their routing updates and learn about the network paths in other sites. So we can have a look at the configuration for EIGRP protocol. Also, before showing the configuration, I would like to tell you that I have configured EIGRP protocol between the edge router and access router of site A. I've configured OSPF of the protocol for routing updates on the link connected to edge router and access router of site B, and I have used RIP routing for dynamic routing protocol on site C between the edge router and access router. So I'll show you the configuration for all the three protocols. As we can see that I have created this router process for EIGRP and I have defined the networks to which the EIGRP packet should be advertised. Also, I have disabled auto summarization, which will disable the auto summarization of subnet level routes into network level routes. I have defined MD5 authentication on all the links which are connected to other routers. So may it be EIGRP or OSPF protocol, I have defined MD5 authentication on all the interfaces which are connected to other routers. So this is the configuration for MD5 authentication, in which I'm using a keychain named as site security, and this is going to hold the key which will be used for authentication. So the purpose behind including MD5 authentication is that we need to ensure that the routing updates and the information which is shared by other routers is legit, and we need to ensure confidentiality. So that is the reason I have included MD5 authentication on the interfaces. Now we can look at the configuration of EIGRP and OSPF on edge router of site B. Here, rather than showing the running configuration, I would like to show the IP protocols which are running on this router. So as we can see that there is EIGRP configured, and these are the network paths to which the EIGRP packets will be advertised. Also, there is OSPF, which is configured between the edge router and access router of site B. And here is the network path to which the OSPF packets will be advertised. Similarly, on site C, I have configured EIGRP and RIP protocol. So this is the configuration for EIGRP and RIP, wherein I have defined the network paths, and I have also defined no auto summary to disable auto summarization. Now, once these routing protocols are configured, they will try to exchange the routing information with another router using the same routing protocol. But let's assume that EIGRP on the edge router will learn the routing updates from site A because the link is configured with EIGRP dynamic routing protocol. Also, site B edge router is going to learn about the network paths from access router of site B. But the thing here is that the network paths which are learned by two different protocols won't be shared with each other. And that's why site A won't know about the network paths which are learned using OSPF protocols over here. So what we can do is we can use redistribute command, which will allow both the dynamic routing protocols to exchange the routing information with each other, and that will help all the routers to learn about all the network paths in this network topology, and that will help all the workstations to communicate with each other. So I have used redistribute command on access edge router of site B and edge router of site C because only those two routers has two dynamic routing protocols configured on them. So I can show the configuration for a distribute command. So what I have done is I have entered the routing process for EIGRP protocol, and I have used redistribute command for OSPF. And here I have defined the metric values. 1000 means the bandwidth, 33 means the delay, 255 means the reliability, which is the best. 1 means load, and 1500 means the MTU size. Similarly, for EIGRP, I have entered into the OSPF routing process and I have defined redistribute command for EIGRP routing process 1 and for all the subnets. So this will help the router to learn about network paths learned using both the dynamic routing protocols. So now I would like to show the IP routes which are learned on this router. And as we can see that there are routes which are learned using the OSPF protocol and there are routes which are learned using the EIGRP protocol. Also, DEX means the external networks which this router has learned using the EIGRP protocol. So this basically means that because of the redistribute command, it is able to learn about all the network paths. Similarly, we can see the IP routes on edge router of site C. And similar to site B edge router, this router has also learned about all the network paths using the RIP routing protocol and EIGRP protocol. Now we can try to communicate from PC site C to the web server. And we can try to access the custom page which is configured. And we can successfully see the custom page which is configured. We can also try to ping any workstation in site B. And as we can see, we are successfully able to communicate with the PC in VLAN 10 of site B. So this shows that our configuration in this network diagram or in this network topology is working as it is required. That's it for this video. Thank you so much.